Welcome back, Year 10, on this glorious Wednesday. I know you're going to be excited. Today we're looking at how our bodies respond to exercise and how we use those products of respiration to respond to the changes in heart and breathing rate to ensure that our body delivers sufficient oxygen to perform our best. So, quick quiz, 1 to 5. Okay, this is going to be a quick one. Quickly write down what you know about the following 5 things, and we'll go through the answers in a second. Please pause the slide. So, number 1. What is the word equation? Glucose plus oxygen. Doesn't matter which way round, you have those reactants. Gives me CO2, water, and energy. Remember, chemical name for energy is ATP. What is respiration different from breathing? So respiration is a chemical reaction, whereas breathing is the physical, mechanical process of pulling that oxygen into our body. Number 3, what is the name of the organelle? Mitochondria is the plural, mitochondrion is the singular. And number 4, what is the word equation for photosynthesis? Look, oh, surprise, it's the reverse of our equation for aerobic respiration. And number 5, why is respiration considered an exothermic reaction? The chemical reaction releases energy necessary for life processes. So therefore it doesn't require energy to start the reaction, but it does release it. Remember, photosynthesis is endothermic, respiration is exothermic. So, energy for movement. Now, why is it so important? If you think about us as humans, we are built of muscles. And muscles require lots of energy. Now, I did ask you in yesterday's lesson to think about why skin cells have less mitochondria than muscle cells. And that's because muscle cells require more energy to carry out their function, to contract. We have 3 different types of muscle. We have skeletal muscle, smooth muscle, and heart muscle. And each one of those will require oxygen for aerobic respiration. You may want to make a note of these 3 different types of muscle to ensure that you understand what they are and how they are different from each other. So, muscle tissue is made up of cells that contain protein filaments that they can slide over each other, causing the muscle to contract. Muscle cells contain many well-developed mitochondria. The more mitochondria there are, the more energy they can release, and therefore the more contraction that can occur. Muscles store glycogen, which is made up from glucose and can be converted back to glucose very rapidly during exercise. So, the more muscles you build during your training as an athlete, the more you can respond faster to the need for more energy. So, what we're going to do is I'm going to ask you to pause this in a second. You're going to summarize all of this information into 90 words. No more than 90 words, because actually what we often do is just copy everything out. I want you to pause the slide and spend your time thinking about what it is in this passage that is important, and give yourself a brief explanation of the important points and its relevance. Pause the slide now. So here's one I did earlier, okay? And you've got your example summary, and did you get all your key points? Now, we often find when the most successful people, when they're coming to revising, aren't those that work the hardest, but they're the ones that are able to summarise that information more effectively. So here we've got our summary. Now, I've only used 79 words in my summary, so I know that I'm nowhere near the limit. The less words they are, means that the more effective it is I'm going to be at remembering the content of those words. I can highlight those words in bold to ensure that I've understood which ones are the key points, which draws my eye to specific points within the text. You can use highlighters for this. But notice you might also want to add a couple of pictures for this, just to give yourself a visual hook into this activity. So, we're going to do a bit of a practical, and you can do this at home. Now, hopefully, you've all been working out with the Joe Wicks video every morning, been pumping some iron, doing your squats and all that business. And this is a mini practical, just as you would do in school. If you were at school, we'd have you all jumping up and down, doing star jumps, step-ups onto the benches, running up and down the stairs. It would have been craziness. So here is a chance for you to go crazy, guys, in your own home. First of all, we're going to write down our hypothesis. Remember, that's what I said, is what you think is going to happen. So do you think that your heart rate is going to go up, down, or stay the same during exercise? Write down your idea now. And then you're going to measure your pulse. Now, it's really important to use 2 fingers when counting your pulse. And you can measure your pulse in a whole variety of areas, in your neck, in your wrist, or in your groin. You need to push quite hard with those 2 fingers until you can feel the blood just gently pulsing under your fingers. Now, anywhere where the artery crosses a bone, can you find that pulse? I would suggest your wrist, but if you want to try your neck or your groin, that's knock yourselves out, guys. Once you've found your pulse, count the number of beeps for 15 seconds. Use your phone, I'm sure it's in your other hand, to count and measure the time. 15 seconds. Then you're going to multiply this, not mousify, multiply this by 4. That will give you the number of beats per minute. Rocket science, this stuff, guys. Rocket science. Write it down. So, health and safety. Now, first of all, make sure that this area is clear. Please do not be doing this in your kitchen or anywhere where you're going to irritate your parents, because I don't want any complaints. Also, please don't do it so you're going to fall through a window or break anything. The NHS is under a lot of pressure. So, you're going to stand up. You can jog on the spots. You can do your push-ups. You can do your star jumps. You can do whatever you want, but you're going to do it for 2 minutes. Set a timer on that phone. I'm sure it's still in your other hand. And you are going to get that heart rate going. This might be the most exercise some of you have done since we broke up. Otherwise, some of you may have been using your hours worth of physical exercise recommended by the government very wisely. So, start your timer now. Once your 2 minutes is up, which that wasn't 2 minutes, but once your 2 minutes is up, take your pulse again and write it down in your book, on a napkin. Don't write it on the wallpaper. And what we're going to do is look at whether or not your pulse has gone up or stayed the same or gone down. Whilst you're waiting to think about your ideas of whether or not your pulse has gone up, down, or whether or not your heart's not beating at all, in which case I'm concerned, I want you to think about what's different about your breathing. How does your skin feel in response to doing your 2 minutes of physical exercise? If you're feeling unwell, now is a good time to sit down. Record your observations. If your mum or dad or aunt comes in and says you don't look well, lay down. Thanks. So, when we're exercising, we need to think about lots of things that are happening within our body. And there are lots of what we call automatic responses. You're not having to think about how your body's responding to that exercise. It just does it automatically to ensure that your muscles get the delivery of oxygen that they need. And we talk about your muscles being a respiring tissue. It's where respiration's taking place. What you'll see is that the blood flow will increase. So not only does your heart rate increase, which means that it's beating more times a minute, it also increases in its volume. We call that the stroke volume, And the volume in which the heart of blood within the heart, each time it contracts, is larger. And that allows us to deliver more blood to the cells more frequently. Now, that's no good if we're not picking up more oxygen at the lungs. Just an equation again there for you in case you'd forgotten what we were talking about. And the rate of respiration in the cells increases, but we are requiring more and more oxygen. So what you also see is our breathing rate increases. So you breathe more, but you also breathe more deeply. And that means that your body will bring in more air into your lungs, more oxygen into your blood, and more carbon dioxide from your blood plasma back into the lungs. And when the blood glucose levels fall, glycogen, okay, is converted back to glucose through that amazing chemical called glucagon. So you need to make sure that you know the difference between the rate and depth of breathing and the breathing rate and the rate of respiration. So breathing is just the mechanical putting oxygen into our body, whereas the rate of respiration is the rate at which the chemical reactions are taking place. So study this graph. Riveting. Some nice primary colours going on there. So basically, the more intense the exercise, the greater the breathing. Which of these statements is true? So we've got reading a book. Some of you may have been doing this. Walking along the beach, walking up the stairs, running on the treadmill. And up the y-axis, we've got the breathing rate per minute. Which one of these statements is true? Take a second. So I would say that the first one is true. The more intense the exercise, the greater the breathing rate. Study the next graph. This time, this is a nice line graph. We've got a fit person. That was clearly Mr. Deaton, and an unfit person, which is clearly me. And we are both doing some exercise, obviously not together because we are social distancing. And he is running on his treadmill at home, and I am running on my treadmill at my house. And what we're looking at is which of these statements is true. So, the heart rate increases during exercise. Yeah, both of our heart rates increase during exercise. The recovery time is the time it takes for the heart rate to return to its resting value. And a fit person's heart rate returns to normal value more quickly. And a fit person has a higher heart rate. Now, you'll notice that not all of those statements are true. Our heart rate isn't able to return to normal straight away. The more unfit you are, the longer your recovery time. Okay? And the fitter you are, the lower your heart rate is in general, exercising and at rest. Note to self, join gym. So, key points from today's lesson. I suggest you write these down because actually they're quite important. This is quite a conceptual lesson, and although I've had a bit of a giggle about doing the exercises, it is one of those lessons that they will test in a variety of different ways in the exam. They want to know that you understand that the energy transferred during respiration enables muscles to contract. Without that contraction, our bodies cannot respond to that demand for energy. And therefore, also, we need to be able to have those muscles to contract for our own protection so that we can move safely to places out of the way of other dangers. We need to be able to contract our muscles so that we can move and keep warm. We need to be able to respond to ensure that we are safe at all times. The body's responses to exercise, we need threefold. First of all, we increase the heart rate, breathing rate, and breath volume. Then we also use up our glycogen stores for cellular respiration, and the flow of oxygenated blood to the muscles increases. That's why our skin appears a pinkish colour after we've been exercising. And these responses act to increase the rate of supply to glucose and oxygen to the muscles and the rate of removal of carbon dioxide from the muscles. If we don't remove that CO2 from the muscles, then that CO2 can become quite damaging to our tissues. And we're going to learn a little bit more about that in tomorrow's lesson. So, because we love a bit of SAM learning, I now want you to complete the self-assessment quiz on respiration and exercise. It's great, SAM learning, because it gives you a score at the end. If you don't get 50%, I want you to have another crack at it, because it means that A, you haven't quite understood the content of today's lesson, or B, you weren't really paying attention. Not that I'm insinuating that you're sitting there watching daytime telly rather than listening to me. So what I'd like you to do is to have a go at both the one SAM learning quiz. I really would like, if you're really unsure and you're really stuck, email me. I'm lonely. I'm sitting here making YouTube videos. I really, really I'm looking forward to hearing from you. And some of you, well, about 273 of you, still have got homework from yesterday to do. So crack on, guys. I'm looking forward to hearing from you. Bye.